Welcome to my channel. We will discuss scalar and vectors. In physics, physical quantity are distinguished according to magnitude and direction, so that there are two types of physical quantities. First one is the scalar and second one is the vector. Therefore, we are going to discuss scalar and vector. First one, scalar means what? For example, we measure the length of this pen is supposed to be, for example, 7 centimeter. This 7 centimeter is sufficient to explain the length of pen. 7 centimeter is necessary to explain the length of pen, and therefore 7 centimeter is the magnitude of length, and hence length is the scalar quantity. Length is the scalar quantity. In case of another term, means for example work, whenever we apply the force on this block, therefore the direction of this force along the direction and displacement along the direction, and therefore the work is the product of force and displacement, and to explain the work, it is necessary only magnitude of force and displacement, so that work is also scalar quantity. In another example, current, whenever the current flowing through conductor, for example, we have a rectangular conductor. Rectangular conductor. In this case, current flowing through this direction. But here also magnitude for 5 ampere, 5 ampere, 5 ampere, 5 ampere. Means in this case, in case to explain the current, we have taken only magnitude. We don't think about the direction of current, so that current is also scalar quantity. How to define the current? Current can be defined as the rate of flow of charge. Rate of flow of charge. Only in this case, it is necessary to magnitude of current, and therefore how to define scalar? Scalar is defined as the physical quantity, which can describe by magnitude only, magnitude only is called the scalar quantity. आता दूसरा एग्जाम्पल हो गया. एज एग्जाम्पल का लेंथ, मास, टाइम, टेम्परेचर, वर्क, etc. These are the example of scalar quantity. How to explain the scalar quantity? The physical quantity which can describe by magnitude only is called as the scalar quantity. You remember this. For the scalar quantity, it is necessary only magnitude of that physical quantity. To explain the scalar, it is necessary to explain the magnitude only, and therefore example length, mass, time, temperature, work, and so on. Next physical quantity is the vector. Means for example I am standing here and I move from this point. Suppose A is on which side? West side, and this one is the east side. As I move from west to east through 5 meter, then we explain the displacement. Why? In case of displacement, it is necessary magnitude as well as direction. To explain the displacement, it is necessary magnitude as well as direction. When I say only I travel distance 5 meter, then it explains magnitude only, and this is the distance. But when I say I displace through 5 meter from east to west, this explains the displacement, and to explain the displacement, it is necessary magnitude as well as direction. it is necessary to explain magnitude as well as direction. Means, for example, to explain the displacement, suppose initial point is A and final point is B, and suppose this is the small vehicle, and as this vehicle move from point A to B through, for example, this distance is 7 kilometer, and suppose this travels through 7 kilometer from A to B, 7 kilometer from west to east, this explains the displacement. That is, to explain the displacement, it is necessary magnitude, 7 kilometer is the magnitude as well as its direction from west to east, and therefore it is sufficient to explain the displacement. And therefore, whatever may be the vector quantity, how do you define it? The physical quantity which can describe by magnitude as well as direction, is called as the vector quantity, the physical quantity, described by magnitude as well as direction, is called the vector quantity, For example, displacement, velocity, acceleration, force, etc. Means, to explain displacement, velocity, acceleration, force, it is necessary magnitude as well as direction. Therefore, these quantity are the vector quantity. Means, how to define vector quantity? The physical quantity which can describe by magnitude as well as direction. The physical quantity which can describe by magnitude as well as direction is called as the vector quantity. The physical quantity described by magnitude as well as direction is called as the vector quantity. Example: displacement, velocity, acceleration, force, and so on. Now listen here, important thing is that vector always denoted by arrow drawn overhead of symbol. The vector represented by the arrow drawn overhead of symbol, that is A bar. Its magnitude is represented by modulus of vector or A only. This representing magnitude as well as direction of a physical quantity, and this represent only the magnitude. Now listen here. आता आपण काय डिस्कस करू, how to represent vector by graphical method. How to represent the vector quantity by graphical method. By the graph. Idapa, consider Consider we have xy plane, x y plane. In this xy plane, O is the origin, and here we draw a vector force F bar. F bar is represented by OA. F bar is represented by OA. F bar is represented by OA. In this case, length of OA represents the magnitude of force. Length OA representing the magnitude of force, and direction of this arrow OA represents the direction of force. Direction of OA represents the direction of force, and length of this arrow represent the magnitude of force. Magnitude of force. In this way, we can represent the vector quantity by graphical method. Now listen here. Positive, negative, and unit vectors. Means define the terms. First one, number one, equal vectors. Number two, null vector. Number three, negative vector. And number four, unit vector. Now listen one by one. First one, equal vector. First, we are discussing equal vector, null vector, negative vector, unit vector. मग पाहता इथं फर्स्ट वन इज इक्वल वेक्टर. इक्वल वेक्टर Consider we have two vector. Suppose vector A bar and vector B bar. Vector A bar and B bar are the displacement vectors. Having magnitude of A bar 8 centimeter, magnitude of B bar 8 centimeter, as well as direction of A bar and B bar are same, therefore they are called equal vectors. Therefore A bar and B bar are called equal vectors. For example, we have another vector C bar and this one is the D bar. C bar, D bar. But in this case, magnitude of C bar 8 centimeter, magnitude of D bar 8 centimeter, but direction are different. Therefore, C bar not equal to D bar, but in this case A bar is equal to B bar. Why? Since the magnitude of A bar and magnitude of B bar are same, as well as direction of A bar and B bar are same, so that A bar and B bar are the equal vectors. A bar and B bar are equal vectors. Why A bar and B bar are equal vectors? Since the magnitude as well as direction of A bar and B bar are same, therefore they are called equal vectors. But in case of C, magnitude are same. Magnitude of C bar and D bar are same, but direction are not same. Therefore, they are not called equal vectors. Now, how to define equal vector? The two or more vector having same magnitude and same direction, are called equal vector. The two vectors having same magnitude magnitude, as well as same direction are called the equal vectors, are called equal vectors. Means two vectors having same magnitude and same direction, are called the equal vector. For example, A bar and B bar. A bar and B bar, same magnitude, same direction, therefore they are called equal vectors. Next, null vector. The vector having zero magnitude. The vector having zero magnitude is called the null vector. A vector having zero magnitude is called the null vector. For example, consider we have two vectors, A bar and whose magnitude 5 centimeter, another vector B bar whose magnitude 5 centimeter, but both are opposite in direction, and suppose C bar is the addition of these two vectors, but the direction of both vectors are opposite, therefore we are taking 5 plus minus 5 is equal to 0, and C bar is called as null vector. Why? A and B are not null vector. A bar having magnitude 5 centimeter, but direction from west to east, B bar east to west, and addition of these two is equal to what? 0, and addition is equal to 0, that is the magnitude of vector C bar is 0, and therefore C bar is called the null vector. Next important definition is the unit vector. Unit vector. Consider we have a vector A bar. And its magnitude mod of A bar is equal to 10 centimeter. Taking another vector here, small vector A bar, but whose magnitude is equal to 1 centimeter, and in a direction of A, so that this small letter A bar is the unit vector. Now, how to define unit vector? A vector having unit magnitude. A vector having unit in magnitude is called as unit vector. A vector having unit magnitude. Is called the unit vector. In this case, A bar representing magnitude as well as direction. Here A bar represent magnitude as well as direction, but A bar represent mod of A bar represent magnitude only, mod of represent magnitude only, and his direction represented by A bar. Why? A bar represents the direction of A bar. Why? The direction of A bar is same as the capital letter A bar, and unit vector always denoted by a vector over its head. A small cap is drawn over its symbol. A small cap is drawn overhead of the symbol. Unit vector always represented by the small cap drawn overhead of the symbol or bar only. Therefore, A bar represents direction of A bar. And how to write A bar? This A bar represents magnitude as well as direction. This represents only magnitude, and whose direction is represented by A, so that multiply to magnitude by a unit vector A cap. Means in this case, A bar representing magnitude as well as direction, mod of represents magnitude, and A cap represents direction. Here या ठिकाणी जर म्हणलं आपण मॅग्निट्यूडमध्ये काय चेंज होईल का ए बारच्या, तर होत नसतो. इथं बघा याचं मॅग्निट्यूड किती आहे 10 सेंटीमीटर, याचं मॅग्निट्यूड किती आहे 1 सेंटीमीटर. 1 into 10 1, so that magnitude remains same. Therefore unit vector represents only direction, and therefore finally we get A cap is equal to A bar upon mod of A bar. म्हणजे युनिट व्हेक्टरचा फॉर्म्युला कसा डिराईव्ह करणार आपण? युनिट व्हेक्टरचा फॉर्म्युला असा डिराईव्ह करणार, द रेशिओ ऑफ a vector to its magnitude. Unit vector also represent unit vector is equal to ratio of vector to its magnitude, Once again I told you definition. A vector having unit magnitude is called as a unit vector. And consider we have a vector A bar whose magnitude is 10 centimeter and direction from west to east. Another vector along the direction of A bar, which is the small letter A cap, whose magnitude is only 1 centimeter, but direction of A cap and A bar are same, so that A cap is called the unit vector of A bar. A cap is called the unit vector of A bar. And A bar represents magnitude as well as direction. Modulus of A bar represents the magnitude only. A cap represents the direction of A bar, and therefore we get A cap is equal to A bar upon modulus of A bar. A cap is equal to A bar upon modulus of A bar, and therefore unit vector is equal to vector upon its magnitude. But in case of plane, x y axis, and in case of 3D, in case of 3 dimension, there are x, y and z axis. Therefore there are 3 rectangular unit vectors in 3 dimension. In a 3D, how do you represent unit vectors? They are called as the rectangular unit vectors. Consider in 3D means there are 3 mutually perpendicular axes x, y and z. X, y and z axes are the mutually perpendicular vectors. In this case, I cap, j cap and k cap are the unit vectors. I cap along the direction of x, so it is the I cap is the unit vector of x. J cap is directed along y axis, so that j is the unit vector of y axis, and k cap along z axis, so that k cap is the unit vector of z axis, means that is I, j and k are the rectangular unit vectors. Rectangular unit vectors. Rectangular unit vectors directed along x, y and z axis respectively. X, y and z axis. Keep in your mind, I, j, k are the rectangular unit vector directed along x, y and z axis. Therefore, they are called the rectangular unit vector of x axis, y axis and z axis. And magnitude of I, j, k are 1. I, j and k are 1. Magnitude of I, j, k are 1. Keep in your mind. I represent the direction along x axis, j represents the direction on y axis, k represents the direction of z axis. Now listen here, another vector, negative vector, negative vector, negative vector, negative vector, negative vector, negative vector. Consider we have two vectors a bar as well as there are another vector b bar and their magnitudes. Mod of a bar is equal to 10 centimeter, mod of b bar is equal to 10 centimeter. Both having same magnitude, same direction, therefore they are equal vectors. Now we are taking another two vectors c bar and d bar, c bar and d bar having magnitude of c bar 10 centimeter, magnitude of d bar 10 centimeter, but direction are opposite. Therefore, they are not equal vectors. C bar is not equal to d bar, but having same magnitude opposite in direction, so that d bar is called the negative vector of C bar. Now, how do you find negative vector? A vector having equal in magnitude but opposite in direction are called negative vector. Are called negative vector. A vector having equal magnitude but opposite in direction to another vector. Such vector is called negative vector. Negative vector of that another vector. A vector having equal magnitude but opposite in direction is called the negative vector. Now listen, important thing, in case of vector addition, subtraction and multiplication, means in case of algebraic method, here we are taking a and this b, length of a, this means a is equal to 5 centimeter, b is equal to 5 centimeter, therefore a plus b is equal to 5 plus 5, 10. In this case also, this c, this also d, and addition of these two, for example, c plus d 7 centimeter, d also 6 centimeter, therefore c plus d 7 plus 6 is equal to 13 centimeter. Means here not thinking about its direction, but in case of vector, algebraic methods are not useful for addition, subtraction, multiplication, and therefore we are using geometrical method for vector addition. You remember, इकडे लक्षात ठेवा important thing, Very important thing is that for vector addition, subtraction, multiplication, algebraic method are not useful. So we are using geometrical method, and which is very important, which is very important. State and explain. State and explain law of triangle for a vector addition. Law of triangle for a vector addition. Question can be asked. State and explain the law of triangle for the vector addition. Law of triangle. Law of triangle for vector addition. For vector addition. Law of triangle for vector addition. Consider we have two vectors P, we have two vector P bar and Q bar, as well as here another vector Q bar, and third vector is R bar. And we are going to taking addition of P bar and Q bar, and which is equal to R bar. So that here we are taking triangle ABC. ABC means this triangle ABC. In this triangle ABC, here we draw a vector AB, and this vector AB represent magnitude and direction of P bar, and this BC represents the magnitude and direction of Q bar. Magnitude and direction BC represents the magnitude and direction of Q bar, and AC represent the magnitude and direction of resultant R bar. Keep in your mind, in a triangle ABC, side AB represents magnitude and direction of P bar, BC represents the magnitude and direction of Q bar, and AC represents magnitude and direction of R bar. म्हणजे या ठिकाणी नीट लक्ष द्या, AB bar represent magnitude and direction of P bar, BC bar represents the magnitude and direction of Q bar, and AC bar represents the magnitude and direction of resultant R bar. परत एकदा सांगतो, AB bar represents the magnitude and direction of P bar, BC bar represents the magnitude and direction of Q bar, and AC bar represents the magnitude and direction of R bar. AC bar represents the magnitude and direction of R bar, and therefore according to law of triangle, AC bar is equal to what? AC bar is equal to AB bar plus BC bar. AB bar plus BC bar. Now, how to state this law of triangle? From this diagram, here keep concentrate on this diagram. AB, this vector, BC, this vector, and third is the AC. Now, how to represent? The two vectors are represents magnitude and direction by two sides of triangle taken in order. इथे लक्षात taken in order म्हणजे कसं येतं? ऑर्डर घ्या कशी किती? AB BC. AB BC means P and Q bar means two vectors. If two vectors are represented in magnitude and direction, two vectors are represented in magnitude and direction by two sides of triangle taken in order means AB BC, and the resultant is represented in magnitude and direction by remaining side of triangle, drawn from starting point of first vector to the end point of second vector. This is the statement of law of triangle. परत एकदा सांगतो law of triangle चा statement. If two vectors are represented in magnitude and direction by two sides of triangle taken in order, that is AB BC, and their resultant is represented in magnitude and direction by remaining side of triangle. Remaining side of triangle means AC drawn from starting point A and end point of second vector C. Now, what is the statement of this law of triangle? If two vectors are represented in magnitude and direction by two sides of triangle taken in order and their resultant is represented by remaining side of triangle. Resultant represented in magnitude and direction. Magnitude and direction by remaining side of triangle. This is a statement. परत एकदा बघा. If two vectors are represented in magnitude and direction by two sides of triangle taken in order, and their resultant is represented in magnitude and direction by remaining side of triangle, and therefore according to law of triangle, in this triangle, AC bar is equal to what? AC bar is equal to AB bar plus BC bar, and but AC bar means R bar, AB bar means P bar, and BC bar means Q bar, and therefore finally we get R bar is equal to P bar plus Q bar, and R bar is the resultant vector of P bar and Q bar. Means R bar is the vector addition of vector P bar and Q bar, and this law of triangle is the geometrical method for vector addition of two vectors. Thank you.